Hello and welcome back. You're tuning into the Ergo Cast, episode 3, the place you should come to when feeding your curiosity surrounding Ergo. Today's episode is going to be mainly focused around decentralized Oracle pools, the latest release to the Ergo ecosystem, and we'll be looking at how they come to achieve their incentives and how they assure reliable data feed. For this show, I will be the host, but in future episodes to come, it will be me and Rob taking part hand in hand. Speaking of which, without ado, I'd like to introduce our guests to the ErgoCast today. We have Robert Kornacki, the man behind Oracle Pools, who is also known as the Head of Research and Development at Ergo. Robert has been a long-standing core dev at Ergo and has made many contributions to the platform. Alongside Rob, we have Amitabh, who is also commonly known as Scala Hub. Amitabh has made accomplishments for Ergo in the fields of cryptography. He is the man behind Ergo Mixer, which is a privacy-enhancing feature for transactions on Ergo. And along with Rob, he has made Oracle pools what they are today. So with all of that on the table, I'd like to introduce you both to the podcast.
Thanks for having us on. I'm glad to be here, and I'm glad the Ergo Cast is back in action.
For sure. There's been a lot already. So, as you can expect, we have a lot on offer today as to what can be discussed. The Oracle pool concept is unique. It offers a lot on the table that you can't really find elsewhere within the environment. So to start off, I think it would be nice if we laid down some groundwork and built from the base upwards as such, before we get into the context of smart contracts and how we can utilize the Oracle pools within Ergo. To get things started then, let's look at the preliminary need for Oracle pools. Why do we need Oracle pools, and are the current solutions insufficient, I guess would be a question.
Sure, so I'll take this from the get-go. So Oracle pools are a concept that we require incentives in order to keep oracles in check. And subsystems out there in Ethereum, some of the older ones especially, don't really have that many incentives in place. They just have tokens and kind of hopes and promises that hopefully one day we'll have everything work out. And that's not really that great when you have essentially centralized actors, typically big companies, which control all of these data feeds. And so Oracle pools are an approach that tries to go from the ground up to have a base framework that allows us to have an epic structure, which both me and Amitabh, we came together and kind of figured out on the extended UTXO model, what are the different approaches for creating epics. And that was kind of a cool first brand new design pattern that really came out of building these interesting dApps like Oracle pools, which maybe we can get into a little bit later on past this overview. But essentially, Oracle pools provide us time, so epochs, where data points must be posted. And with the time being the base, and then having multiple oracles be part of a pool, you now have these very initial base parameters and facets that are required to then build more complex incentives, disincentives, consensus, and all sorts of more complicated and interesting facets that we want out of oracles. And so Oracle pools are an attempt to get the base right, so then we can also experiment going on into the future. Hey, what if we want to try these kinds of disincentives with this kind of consensus? And then what if we add this layer and this layer together? And having that base allows us to do that. And so that's what we set out to do with Oracle pools.
So in some sense, the Oracle pool as a methodology is tying things all together and putting some constraints on how they should function and be part of a system. Could I say it as that, maybe?
Yeah, I think that is the case. And some of the cool parts of Oracle pools too, for us, I think, in the Ergo community, is just figuring out how can we make a lot of this work. The initial idea was to improve on what's out there and kind of look at the different incentive structures that are available in different Oracle projects. And some of them are cool, but require like proof of work mining. And you kind of have the question, I think that's like Teller, where is that really scalable? If you have to proof of work mine to get all your Oracle data on chain to have these incentives, well, that's, we're having scaling problems with proof of work currencies on uh, in regards to just TPS for normal stuff. But then if you have to put $10,000 worth of mining just for Oracle data, does that make sense? Probably not so much. And so having this sort of basic Oracle pool approach and kind of experimenting with different design patterns allows us to have a lot of expressibility. And so, I mean, if you want to jump in here, Amitabh, and kind of talk about our initial attempts at, creating these Oracle pools, feel free to jump in to talk about maybe the epic structure and how that all went.
Yeah, sure. So initially, we had various ideas like how do we define this epoch structure? So there are various ideas like would we have a fixed epoch or would we have a dynamic epoch? So fixed epoch is a problem because we need to synchronize a lot of participants, and that kind of tends to be a problem in a distributed system. Yeah? So the idea was then to have both variants, right? So we have a dynamic epoch variant also, but there are certain features that we have in the fixed epoch variant that we don't have in the dynamic one, such as stake slashing and all. So finally, we decided to have a epoch preparation period during which we can have a dynamic nature, so that epoch preparation period can actually go longer than what is designed, and then we go into a recovery phase, which is create a new epoch. So this kind of structure encompasses our earlier model of dynamic epoch and also gives us the benefits of a fixed epoch. Yeah? So that's what we have right now.
So it seems as if you went through multiple different options for the structure of the data points and epochs as a whole. And just in case some of the viewers at home don't understand what an epoch is, it could be summarized as an on-chain event with a period of blocks beforehand, which acts as such as a time frame in some sense. Would that be correct?
So you can just think of it as a slice of the blockchain into several sequential slices, and each slice can be thought of as an epoch. And do we need them to be of the same size, or can the size change? So that's what I mean by dynamic versus fixed. But you can just think of them as slices of the blockchain. That is my way of looking at it. Yeah.
It's very interesting when you think about slicing it up and whatnot. That's definitely something to explore maybe in future episodes, 100%. So from my understanding, blockchains and chains solely on their own don't really have much utility in terms of applications and functionality. But it was sort of when smart contracts came into existence, with Ethereum being one of the first few, that the little light bulb within people's minds started to flicker, and the path paved way to what we are seeing today with this whole decentralized landscape as such. So moving on with that point in mind, would you say that oracles are in some kind of way similar to magnitude that is the same as with smart contracts, if that's clear? Does it create that as much opportunity?
So this is a good question, because in regards to the DeFi craze that we've been seeing, especially over the past few months, but last year or so, oracles are pivotal. But that said, we have really cool dApps on the Ergo blockchain right now. Like, for example, Ergo Mix, which allows you to have mixing in the smart contract layer rather than in the ledger layer itself, which is pretty novel and interesting at a very cheap price. Because there's such things like that on Ethereum or Bitcoin, where you have certain trust assumptions, or they cost you $45 per mix or something, which makes them not really realistic. But Ergo brings out a lot of really neat potential because of all these privacy possibilities, thanks to Sigma protocols at the core of the blockchain and core of the smart contracts. And so in some cases, yes, in regards to DeFi, oracles are such a big revelation. But in terms of the whole state space of potential smart contracts, potential usability, are oracles as big as smart contracts? I think personally, the answer is definitely no. However, they are inherently integral, because we have a outside world where the majority of everything in life happens, and we have the on-chain world. And we need those bridges using oracles to bring data from the real world into the blockchain. And so not all use cases are integral. And eventually, as we start to have more and more and more data actually living on chain or inside chains, within blockchain ecosystems that you have a direct availability of data from, we're going to need oracles less and less because we have stuff like NEPA POWs in Ergo and maybe support the NEPA POW soon, which will allow us to actually have these proofs from other side chains or other blockchains entirely, which don't require oracles because we have actual proof from the blockchain itself. And so oracles, in my opinion, are a big part of the whole picture, but they're definitely not as big as smart contracts, which essentially open up a whole new world. And with that said, I do think that taking these steps forward and really nailing down oracles is probably going to be something that in the blockchain sphere over the next 5 years, maybe 10 years, we're really going to work on and try to figure out to make it as secure as possible and reliable as possible. But there's still so much more potential after that. And so I think it's awesome we're working on this now. And, Oracle pools are one of the first steps towards going that way.
It sounds pretty decent. So to put briefly, Oracle pools expand the functionality of smart contracts instead of adding this whole new wave of potentiality in the same manner, briefly. And with the NEPA POWs, which is a non-interactive proof of work, I believe, that opens a door for a different kind of ecosystem, I guess, where you can imagine these different blockchains with different functionalities being tied together with Ergo at the center and dragging it all along, I guess.
Yeah, Amitabh, if you want to jump in here, if you know a lot about NEPA POWs, I'm not sure. But NEPA POWs are quite interesting because they allow you to have a lot more cross-chain interoperability. And so, Amitabh, if you wish to jump in, please feel free.
So I also probably am not the right person to discuss too much about NEPA POW because it's still on my reading list. But in summary, it allows you to kind of do a lot of proofs in a very, very compact way. Yeah. So, for example, again, this is something that I'll have to verify. But for example, in SPV mode, we still need to have like a login amount of headers, right? But in NEPA POW, it is much smaller. It is kind of login, I believe. So it is basically very compact proofs for statements, arbitrary statements that you want to make off chain. And that's where the what Robert said is probably bang on about oracles. That's the only way to link an external world to our smart contracts. And so they are not as important smart contracts, but they are probably the second important thing, I would say, in my opinion, having oracles, a reliable oracle as such.
I see. You mentioned that the NEPA POWs are very compact. With that sense, could they be easily embedded within these other blockchains? Is it very easy to integrate them with smart contracts and whatnot, in the sense that it is embedded?
So about Ergo, currently the use of NEPA POW in Ergo is basically to have very lightweight nodes, right? So it is not really part of the protocol. It is more of the on top of that. But I believe it can be done in smart contracts, since not in Ergo, but maybe it can be done. Yes, there is no restriction why it cannot be done.
Sounds very portable.
But again, like I said, yeah, my knowledge of NEPA POW, especially related to Ergo, is very limited. So maybe Alex would be the right person to discuss these things. Yeah.
We're going to have to try and bribe him to come back on if that's the case then.
Yeah.
So you mentioned about the epics and the stages within the Oracle pool system. Maybe if we touch ground a little bit on the live epic stage and the preparation stage for the epic, which isn't mentioned within the high-level overview, at least. So while looking at this documentation, which was brilliantly written and very informative, to say the least, It did appear to be two distinct stages, as I just mentioned. And a lot comes across your mind when you read through this paper that's explaining the concept, especially when you hear live epic. It sort of triggers a thought chain of something is taking place here. This is an integral key part.
Yeah, so essentially, these are all the oracles actually submit their data points. And so what that means is that every oracle fetches their data, creates the transaction that posts the data from the off-chain world to the on-chain world, and then that becomes finalized on the blockchain. At the end of the live epic, all of the oracles then rush to find all the other oracle data points, create a transaction to then summarize all of them, so average them out, and then post that as the finalized data point. At the exact same time that this finalization action happens, or this collection, we move from the live epic to the epic preparation stage. What this signifies is that the previous epic has finished, there's a new data point, all of the oracles are paid out, and this is an interim period where you kind of have house cleaning to some degree. And so a lot of stuff can happen here. And so with the current existing implementation of oracle pools, which is the most simple one, we only have the ability to collect funds. So if other people have submit UTXOs onto the blockchain, we can collect them all to bring in the funds so that there's funds to pay out all the oracles for the preceding epics. And we also have the ability to continue to the next epic or create a new epic if for some reason the pool was underfunded, for example, or the next epic did not start because of very, very high congestion. And what's cool about this separation between epic preparation and live epic is that we have the ability to have a lot of complex stuff about, let's say, the governance or stake slashing exist in the epic prep stage. Because the live epic, everyone's active and they're posting their data points, this isn't really a good moment to start changing how much the oracles are going to get paid out, what the funds are. Are we kicking out oracle number 3 because they just seem to be a bad actor? Should we be stake slashing someone? All of these factors don't really work when we're trying to just get through the live epic because they're not really integral to the act of, collecting all these data points and finalizing something, but they're integral to the running of the oracle pool. Therefore, that's why we have the epic preparation stage, so we can do all this housekeeping, governance, stake slashing, and potentially whatever other incentives or disincentives we come up with eventually. They can all happen in the epic prep without actually disrupting the protocol running. And so that's why we have these two stages, so that we can have the oracle pool run smoothly and also have this housekeeping stage.
So the preparation stage could be seen as an optional stage in some sense, as long as everything is fine and working functionally. So if the oracle pool is sufficiently funded, for example.
Effectively, in practice, yes. It's nothing essentially happens if it's well funded. Potentially collecting funds, for example. And so they're not collecting funds from users who posted them previously in the live epic, but in the epic prep. In Amitabh's dynamic epic scheme, initially the idea wasn't even to have an epic prep stage at all. And so depending on the use cases, in some of your protocols, like we have in oracle pools, you want an epic prep to do stuff like stake slashing as well. In other types of in other types of dApps, that might not really be needed. And so it's kind of cool that we have these design patterns, because these are really some of the first design patterns for how do we understand time.
So while he's reconnecting, I'll just quickly fill in. So if you remember, I said, Rob, I'll just quickly fill in what you were saying. So like I said, right, an epoch is basically we slice the blockchain into various kind of slices. So we'll have like 50, then next 50, then next 50. Ideally, we want that, right? Every slice is 50 blocks, and that's fixed, right? That gives a lot of guarantees when we design our smart contracts. But like I said, it's not possible to have everything synchronized. So we cannot really guarantee. And in practice, it is never going to be possible to have start exactly at when the previous epoch ends. So we have this kind of a buffer period where we do all this maintenance, plus we allow for delays in the network. So that is what epoch preparation period is. Basically, it allows you to kind of handle errors. Basically, it's like a failure kind of handling phase. Plus, you can collect funds. And ideally, we want this to be as small as possible, right? So in the design, we try to, if everything is fine, the network is good, and there is no delays, then normally the epoch preparation phase will be very small. Yeah, it will be maybe 1 or 2 blocks only. But we allow it to be extended, right, to take into account network delays and all these failures. So it can extend indefinitely, in fact, this preparation phase.
I see. So a potential analogy for this is the preparation stage is what a pit stop is to a race, if that works well. Yeah. With the live epic and the accumulation of data sources, is this something that the pool operator would take control of on their own accord, or is there some kind of function mechanism that other data sources could use to apply for that Oracle pool?
Yeah, so every Oracle pool, by design, the idea is that they have one connector. This connector is a piece of software which sources data from websites, 26 different exchanges, takes all the data, accumulates it, averages out, and then produces a final data point, which gets posted to the Oracle core, which is the piece of software that creates the transaction, which then posts it on-chain to the Oracle pool officially. The idea with Oracle pools is that everyone sources the exact same data point, and so then you have this redundancy between Oracle as part of the pool. What this means is that everyone must use the same connector, and so everyone sources it in the exact same way. And so with that, we have the ability to have greater assurance, and then potentially, if we want even different types of data summarized and averaged on-chain, you could have 2 or 3 different pools which source different data, or have different averaging functions, and then you could average those on-chain together. And so we can have the flexibility of having greater assurance, but also the potential for different kinds of setups.
That certainly seems a lot more robust than other features we can find out there for sure. Leading on from that then, and thinking about the incentives and punishments that are imposed within Oracle Core, how do we remove the bad actors from the system? How do we punish the ones that are trying to imitate other Oracle pools? So people would potentially send the wrong funds to the wrong pool, along with people just acting mischievously, trying to remove the integrity of other data sources and things alike.
So regarding failures, right, or misbehavior. So the way the contracts are designed, there is not too much flexibility for an attacker to misbehave. There are a couple of things he can do, right? So one of the things he can do is he doesn't post the data, yeah, or he posts wrong data, or he doesn't collect every data point. So basically, there are 3 or 4 kind of attacks that are possible, and each of them has certain kind of ways to overcome, but not 100%. So for example, one of the attacks is that there is a set of oracles that will post the data points during the live epoch phase, and during the preparation phase, one of them will collect them into a single data point, take the average, and then publish that. Yeah? So maliciously, he might not collect every data point. He might skip certain ones. So this is the kind of where we get into stake stashing. Right? So if we find out that some actors misbehave, then there will be some penalties in the future. So that is what will prevent them from misbehaving, some sort of a punishment, maybe. Yeah. Plus sorry, I'll just add one more thing, Robert. So there's a few safeguards in the contracts as well. Yeah. So you can't post data points that are too much different from the others, right? So there is a deviation threshold, and all the oracles. So first of all, the data must be sorted, and the data of each oracle must be within a certain threshold from that of the previous oracle, right? So there are certain safeguards inbuilt in the contracts as well. Obviously, we can't stop people from copying the data, so they might not get the actual data, they'll just copy the data from some other oracle. So that is something that we're looking at, but maybe that is one of the attacks that we haven't really addressed right now. Robert, do you want to add to this?
Yeah, sure. So one of the cool things with the deviation check you mentioned too is that we start to have the idea of consensus, where because we have a deviation check, that means that the data points that get collected from other oracles have to be within a specific range. So what we can do is that we can set a number, a minimum, say 3 or let's say 5, and we have 10 oracles in our pool. That makes our consensus 50%, because there needs to be at least 5 oracles who all post a data point within a deviation of, let's just say 1% to make it simple for us. And so if we have 5 data points, each within 1% of each other when they're sorted in a list, then that means we have consensus that 5 oracles all agree that the data point at hand is within this 5% margin. And so in that way, we have this consensus that they all agree. And so even if 4 oracles collude, and they all say the data point is 500% upwards, and they're trying to skyrocket, it doesn't matter because they don't reach that 5 consensus.
So leading on from those 2 previous stages, the live epic and the preparation epic, and thinking about those who can actually supply data through an oracle pool as a data source or data feed, what systems have we got at play that removes the bad actors from an oracle pool, the oracle core as a whole? The ones that are looking to remove integrity and insurance from a data feed, and the other ones that are looking to imitate an oracle pool and potentially steal funds like that.
Right. So in regards to imitation, I'll just mention this quickly. In the extended UTXO model, we use singleton tokens, or better known as NFTs in the Ethereum model in the system, which make your UTXOs unique. And as long as you have a specific NFT or a singleton token with an ID, and you know the ID of the token, no other pool can impersonate you because that's your pool. And the specific set of oracles part of a pool are laid out clearly on chain because they all have UTXOs with their addresses in them. And so no one can really impersonate you and say, yeah, I'm an oracle in X pool, because you can just go to blockchain check and you see who is part of the pool. In regards
so can I just interrupt for a second? I think I'm not very sure what you meant by imitation, but did you mean that imitating a data point, basically copying a data point from an oracle without really getting it from the actual source? Is that what you meant, or what was the attack you had in mind?
Yes. So what is in place that would prevent from someone, say, advertising themselves as another oracle pool in the hopes of, when the replenishment of funds comes along, then taking those funds through the...
Okay, so that is more like impersonation, right? I would say.
Yeah,
exactly. So I was looking at the wrong imitation. I was trying to see how do you prevent somebody from copying your data point, right, without actually getting it from the source. But probably that is not what you had in mind. So please continue.
It's worth covering, though, that's for sure.
Right. And so in regards to the copying of data points within an oracle pool, we've also looked into some of that too, and the potential of having a period where you have the hash of your answer with some sort of salt. And so then you kind of hide, you commit, and then after, technically we would have to switch our stages and have some sort of commit stage, and then your live, or a live epic commit stage and a live epic reveal stage.
Oh, we could overlap them with the live epic, maybe.
Yeah, and so there'd be a bit more complexity, but that's also possible. Other types of ideas we have for the future is also governance. So in our best interest, if we're oracles, part of a pool, if someone always copies someone else, you can see that they're a bad actor. And in the long term, other people can notice. And then if they notice, they'll call you out, and they might try and say, your pool sucks, we're not going to pay you anymore, we're switching to pool YZ, whatever. And so then you can have other external incentives because you actually are providing a service. And if you fail to do your service properly, so then governance should take place and start to make sure that everyone is actually acting accordingly. With that said, in regards to actual incentives and disincentives for getting people to play ball so that you actually have good data points. One of the big upgrades we're making now for the next version of Oracle pools, that's, in my opinion, really a next step up, is that we're adding deviation checking consensus together with stake slashing shortly after. And so what deviation checking consensus is the idea that when oracles submit data points, in the end, what we're looking for is some sort of agreement, consensus. And so what we can do is essentially check that the deviation between every single oracle that submitted a data point, that these data points are, for example, 1% within each other. What this means is that we have a guarantee that all of the data points that get collected and finalized into the new Oracle pool data points at the end of a live epoch, they're actually within a range, within a margin, and that these people agree with each other. And so let's say we have a consensus, a minimum consensus number of 5 in a pool of 10. That means we need to have 5 oracles all post data points within a specific small range, or else a finalized data point won't be posted. So what does that mean? If we have 4 bad actors colluding in our pool of 10, even if they all say the price dropped by 99% and now the cost of ERG is 0.01 cents, it doesn't matter because we have that minimum consensus of 5. So once we have this deviation consensus checking, if we also bring in stake slashing, now we also have a model for measuring the cost of corruption. So if these 4 people have, let's say, 10K, because that's the collateral requirement of our Oracle pool, and that 10K is put up as collateral, if they try and collude, and only 4 of them collude, and the other 6 oracles don't collude, then when the live epoch finishes, those 4 oracles who tried to collude, they all get stake slashed. And so they lose their 40K. And so this acts as an easy way to measure cost of corruption. And so if you have a minimum consensus of 5 and you have 10K per oracle, in a very naive way, not looking at reputation or a lot of other factors or paying off the oracles for their risk and how much each oracle would take for that, we can have a super naive way of measuring the cost of corruption being 5, the amount for consensus, times the collateral, which is 10K, which is 50K in our example. And so in this way, we can have assurance that you will at least need to pay off 5 separate oracles, 10K each, at minimum, very likely in practice, double, triple, quadruple, to pay off for the risk. And in that way, we have assurance of how secure the Oracle pool is.
Sounds perfect. So you mentioned about the consensus that you would find between these different Oracle pools. Is there any tiered system we could find for confidence that would make it easier for a decentralized application or just a general user to choose who to use for a data feed?
Yeah, so what's interesting about the extended UTXO model is that we have data inputs, and data inputs are read-only inputs. So the smart contract of the UTXO does not execute, but you get to read all of the data and coins inside that UTXO. So that is useful because if you have, say, 3 Oracle pools who are all sourcing the data, you can then accumulate their data in like super epochs, you could call them. So you have an epoch that spans all of the epochs of each of the individual Oracle pools, and then the data input is sourcing each of those Oracle pool finalized data points. And in this way, you can accumulate and have higher assurance data because you have more actors which need to be paid off. And so in this way, you can actually measure with a higher consensus and more collateral because you have more people and each of them has to submit collateral. And so this can increase your cost of corruption because as you increase the number of people who need to be corrupted with increased amounts of collateral, in that way you kind of scale your cost of corruption upwards in this kind of 2D fashion. And technically you can have an Oracle pool of Oracle pools and a pool of pools of pools, and theoretically you can turtles all the way up, but have a pool of pools.
Sure. So leading on from earlier, where we spoke about select slashing just beforehand, the epic stages within the Oracle core, and as well as the utilization of oracles and smart contracts, where could you place oracles in the sense of it being a high level feature, a low level? Maybe some people use layer 2, layer 0. I think you get my gist.
Right. So for most people, if you're just an average person and one day you want to use DeFi, you don't really care about oracles. You just assume, hey, someone posted a USD to ERG value on chain. It just exists and it's just true. So from a normal person's perspective, oracles are super, super low level. In terms of the actual blockchain, it's a step above smart contracts. So, you have actual, blockchain, block producers, your consensus mechanism, your cryptography, that's much lower. Then you have your smart contract level of, okay, how do you actually do all this computation? And then afterwards, kind of after that, you have oracles themselves. And from a developer perspective and like building from first principles a blockchain, you could consider oracles somewhat higher up in the layers. But from an actual user perspective, most people won't ever even understand what an oracle is, let alone like use one, because it'll just be within the dApp itself and they're just using the dApp. And so depending on which angle you look at, they're both high level, low level, but they are an integral part of any blockchain that seeks to have smart contract support and actually interact with the real world, which obviously we'd like to do with Ergo.
Yes, so the oracles are very high up and smart contracts are more of a moving force to supporting the oracles in the sense of replenishment of funds and whatnot. Now, if we move a bit further along with oracle's use within the DeFi economy as today, and think about price feeds and their utilization with oracle pools, what would an oracle pool bring to the matter, as we spoke about before, with assurance and data integrity?
So with DeFi, we essentially need price feeds about the state of markets, typically. Most data feeds that are actually used in blockchains today, they're all reporting price of BTC, price of ETH, price of gold, so on and forth. And so what we're essentially doing with oracles is we're summarizing external data, typically about external markets, which are not on the blockchain itself, but are integral to things on the blockchain. One of the things that we are going to be using oracle pools for in the Ergo ecosystem next is a stablecoin. And for a stablecoin, what we need are the actual values of the fiat currency which we're pegging to. And so we'll need to know what the fiat value is compared to the underlying collateral. What our underlying collateral is ERGs. And so we need to know the ERG to USD, ERG to Euro, etc., etc. And so for many DeFi dApps and use cases, really all we need is a external value that we're trying to track or use as a relevant marker or parameter within our equations or protocols. And then that's related to the price of whatever our underlying collateral is within the system. And so in our case, for stablecoins, we're really looking at the ERG to fiat currency data points. And maybe in the future, especially as we look into melding more Ergo and Cardano blockchains and trying to bring them closer together, we might also look into having ADA data points and maybe having wrapped ADA one day in the Ergo's ecosystem and being able to do DeFi where people use wrapped ADA as collateral into stable coins, maybe into synthetics, maybe for loans, who knows what. But all of these things do require oracles, which is why that was the first goal, to build a system that's robust and available for us so we can start to build more and more and more on top.
Sure. So without price feeds, the majority of stablecoins will struggle solely keeping their price equal before a transaction is sent and received. You mentioned about the stablecoin being released on Ergo as being collateralized with Erg. I wonder how that would be achieved. Maybe you could give me some more insight into that.
Sure. So, how most collateralized stablecoins work, without getting into specifics about any given protocol, is that you have two actors part of your protocol: people who want stablecoins and people who want a potential upside and the willingness to accept a potential downside. So what that means is that we have people who are liquidity providers, and they provide ergs in our case, and they want to make more money. And what making more money means is that they want to submit 100 ergs, and then hopefully eventually they'll get 105 ergs or something equivalent to that. So they want a profit. And because they're looking for that profit, they're willing to take on the risk. So these liquidity providers submit their ergs, and then because they submit them, they take on the downside and upside. And so when a stablecoin user wishes to withdraw their stablecoin for ergs, whatever the current rate based off the Oracle data is, they can withdraw their ergs for their stablecoin, and then they deposit the stablecoin, get their 100 ergs, and then boom, bada boom, they're even. They have the stablecoin acts as it's intended to. It's stable. The liquidity provider who provides the ergs that provides the stability for the stablecoin users. These people, if the price of erg to USD goes up, they're happy because now they have more ergs, because the outlying stablecoins, if they get redeemed for underlying erg, they're worth a lot less because the price of erg is higher. So to pay for 1 USD, when the price of erg is 50 cents, you need 2 ergs for 1 stablecoin USD. But if the price of erg is 1 USD, you need 1 erg to pay them back. And so then there's that excess of 1 erg, which then can go to the people who supplied the liquidity. And so people who provide liquidity are betting, they're going long, that the price of erg compared to USD is going up, while people who are generating stablecoin get the assurance that their value will be stable. So when they buy a stablecoin, it'll always be stable.
So there'll be two parties technically at play. One will be locking in, as they are using at the moment, their erg, and while the other one will be generating the stablecoin potentially.
Yeah, so that's essentially how it works. So you have these two parties interacting with the overall dApp, and the dApp may be one or multiple UTXOs. We're still designing the protocol, and depending on if we want to do very high throughput from the beginning or if we want to go more simple, how that's going to be in terms of end user interaction. It's going to be abstracted in the wallet pretty much, but for the actual protocol design, we're still really looking into what's the best way to move forward for this, and that's why we're doing research right now with both IOG, for the Cardano side eventually, which we're also going to be looking into how we can take a lot of the stuff we're building right now on Ergo, into the Cardano ecosystem as well, because it's also extended UTXO model. But first, we're looking at how do we build a lot of this core infrastructure for DeFi on Ergo first, and that's why we have this joint partnership with IOG, or formerly IOHK, Ergo, and the Ergo core devs. And so that's really exciting that we have a lot of these great minds now moving forward, looking into how we can build the best DeFi protocols together. And that's actually in the next quarter, 2 quarters, really going to start to bear a lot of fruit. And so I think that's quite exciting.
It's a very interesting time. So the most profoundly known solution is Chainlink, and it's pretty obvious considering its market cap and the partnerships it holds isn't necessarily the best answer to the Oracle service. As far as I'm aware, the back end is very linear, it's very centralized. It goes from A to B, and that is pretty much it. Maybe you could just quickly expand on that and explain it in better terms for us.
Sure. So Chainlink, one thing that it really has going for it is that it's trying to do everything. And in some ways that's good because, you're trying to take the world for yourself and profit. And so it does a lot of cool stuff, like has options for off-chain computation, which I think is a valid use case, but inherently that's a different set of problems with different security requirements compared to data feeds. And because of that, Chainlink, in my opinion, is slightly all over the place. And that's why you don't really have incentives or disincentives or too much higher level protocols on top of their data feeds. With Chainlink, typically you just have a bunch of trusted centralized companies who are pretty well known, they have a high market cap, and people trust them to have oracles that are accurate. And so you don't have stuff like deviation consensus, for example. You don't really have measuring cost of corruption or any of these kinds of ideas that can really help to provide assurance. You have a token, which makes people a lot of money, and I'm sure for a lot of people that's great. But like in Oracle pools, we don't really need a token. We can use Erg as collateral, and it works very well actually. And it actually makes it easier and better for funding because people can arbitrarily use the UTXO model to create extra outputs and enforce that in dApps to then provide funding to the Oracle pools. With Chainlink, the token essentially acts as a hindrance. And while that's in the case of Chainlink, there's also other projects out there with Teller, for example, which in my opinion, when I looked at the white paper a couple months ago, the token wasn't entirely that useful, but the overall incentive structure is quite interesting in Teller. You have other projects like UMA, which really focuses on cost of corruption. And they have an UMA token, which is quite interesting. And in their case, the UMA token is kind of required because it acts as a sort of sense of collateral. And so the different types of token schemes, which we can embed in oracles, some of them need tokens and some of them don't need tokens. And in my opinion, all of the existing projects out there, they're very interesting and some better than others because they have use cases for the tokens. And being able to use those tokens to measure stuff like cost of corruption is one of the only good use cases, in my opinion. And so for Oracle pools, we realized we didn't really need that. However, in the future, in my opinion at least, Amitabh might differ on this or other people in the ecosystem because we haven't talked in depth about this. Oracle pools are a really solid base foundation. And now that we are working towards cost of corruption modeling within our Oracle pools, that's a really nice step up. But that doesn't mean that we have all the answers, our solution's the best, and everyone else sucks, and we can't learn from them. We can't take some pieces and build on top of what we have. And so one of the things that I'm excited about in a further time scale, say 1, 2, 3 years, is getting Oracle pools as a base foundation as solid as possible, as secure as possible, but then looking at alternatives out there, especially protocols that measure cost of corruption, and then layering those together with Oracle pools. So that Oracle pools could be a layer 1 Oracle scheme, and then you could have a layer 2 that has a different cost of corruption. And then if you have a 2-tiered system, so you don't just have hierarchies, but you can have a hierarchy of Oracle pools and then a second layer of Oracle data assurance, which has a different cost of corruption. Then you actually, in my opinion, have more of a multiplicative effect because the cost of corruption of your Oracle pool system and your cost of corruption of your separate, second layer system, they can actually have an additive or multiplicative effect, because the assurance that you can corrupt one layer doesn't assure that you can corrupt the second layer. And so in a very far time frame, 2 or 3 years, like I was saying, we're not going to have these winner-take-alls. Just like in blockchains, there's not just going to be Ethereum that destroys everyone else. I think a lot of these systems are going to reach their peak potential as we continue to build on them. And then we're going to start to see a melding where we take the best incentives of all of them and then put them together to create the highest assurance possible. And that's why I think our approach with Oracle pools being very flexible and a solid base allows us to have the freedom so that later we can see which of the other competitors have been doing really well and their assurance isn't just in a white paper, but it's actually tested over time and worked. And then we can take the best of what they've done, the best of what we've done, and then build systems that layer together and really solidify Oracle pools, Oracle pools plus plus as the go-to Oracle assurance system.
Sure. So we're going to have an atmosphere of all of these entities being pushed together, and there'll be some kind of outlook born out of all this friction, I guess, would be something I'm seeing anyway.
Yeah, so I just want to add that Oracle pools are a very fundamental primitive for stablecoins, and I think it will be a very important primitive for designing any DeFi apps. So even though we think of it as a layer 2, but I think it is going to be a very primitive, a very fundamental primitive for any application in the future. Right? So Mixer, and maybe there are a few applications that don't need the Oracle pools, but everything else I think of will need something like this. Yeah, they need data from external world, and this is the best solution we have. Like I said, this may not be the best overall, but it is one of the better ones out there. Yeah, compared to what is out. Yeah, so I think I don't have anything more to add. And one of the questions that you asked, right, about the impersonation attacks. So I think Robert mentioned it, but just to add, these are covered by using NFTs, right? So each a pool has an NFT, and our contracts make sure that the payment goes to the NFT. So all those attacks are already handled. So yeah.
So a unique non-fungible token is bound to an Oracle pool as such, and it can't be replicated.
Yep, and each data point as well.
Oh, okay. So from the top to bottom, it's secure. Awesome. So UMA definitely seems like it has a lot of leverage in the space. And as Rob mentioned, as we go further down the line, we'll start to see new concepts born out of the merging of old ones. I feel like one of the best incentives about Ergo for the meantime, and more than likely for the rest of the future, is the nativity side of things. If one was to launch a dApp on Ethereum, for example, they'll be pulling Oracle data from A, they'll be pulling some other data from B, and there will be this whole conglomerate of dependencies that this dApp would be functioning on, which isn't very sustainable when we move towards time. However, when we use Ergo, we have the Oracle pool system, which has been discussed today. We have the stablecoin as an intermediary. And as this all converges together, we're getting this native ecosystem that is going to offer efficiency that you can't get elsewhere. One thing that I am currently aware of is your work, Amitabh, on Kiosk. Maybe you could offer some more insight into what's going on, what it does, and things such as that, etc.
Yeah. So as you know, Ergo is a very powerful platform, right? It has a lot of features in its smart contract, but writing smart contracts directly using the node is not very user friendly, right? So for example, when we develop something like Oracle pool, right, we need to do a lot of testing. We need to create ad hoc contracts and see if they compile, where the errors are. So basically for debugging, right? And node, the Ergo node is not very friendly for these kind of operations, right? So Kiosk is basically a lightweight wrapper around something called AppKit. So AppKit is a tool created by Morphic, right? He's one of the core developers of Ergo. And AppKit replicates more or less everything that the node does, but it is not the node. Yeah, it is different from the node, but it has signing facility, and it is able to get blockchain data from Explorer. So for example, if you need to know the list of UTXOs for a given address, AppKit will pull it from Block Explorer, right? And AppKit alone is not a end user tool. Yeah, it's a library. So in order to use AppKit, you need something to interact with it, right? So Kiosk is basically a wrapper on AppKit, and the main feature is that it is very user friendly, right? So that again is given in quotes because it's user friendly to developers but not to end users, right? So it's designed for developers, and it is basically a way for us to quickly test smart contracts, deploy them, and once we are satisfied, right, then we can actually have a separate code for doing that. Yeah. So for example, for Oracle pool, right? We did all our testing in Kiosk, like the Bootstrap and all. And once we kind of narrowed down to the final version of the contract, then we created a separate Bootstrap module for that, right? So Kiosk is basically something that is used for developers to quickly test Ergo smart contracts, and it is basically made of two parts. So one is the wrapper on top of AppKit. Basically, so using this wrapper, I can call AppKit and say have a method that creates a box, right? A box is a UTXO in Ergo. So it will create a box with certain properties, like it should have this address, it should have these registers. So Kiosk, that wrapper will allow you to do that, right? Then the second part of Kiosk is a very primitive UI that is auto-generated. So it is built on a project called EasyWeb, right? So Kiosk is basically EasyWeb plus AppKit together, right? And EasyWeb basically takes in a random Scala class. You give it a Scala class, and it will read that class, parse it, and then it will generate a very primitive UI automatically, right? So you don't have to write any front end for it. So Kiosk kind of lets you just do the back end work, and the front end is auto-generated. So that way I could focus mostly on the functionality and not worry about how to use it. And it is decent enough UI that we can use, developers can use. Yeah, it is not the best, but it is decent. So that kind of maybe other if you need more information, you can contact me separately, and we have a longer session on it.
Yeah, I'll definitely make sure there's some further coverage or direction put in the description for the viewers. To quickly pack that into something that's more brief, Kiosk is a library or dev tool for releasing and testing onto the Ergo platform. Is that a brief summary, would you say?
It's a library and a front end, right? So it's a library for use for other people to create the app, but it also has a basic front end that we can use it as a node kind of. It emulates the node for developers. So my primary use is to test smart contracts. So I use it as a application, right? But other people can use it as a library as well. For example, Ergo Mixer, part of it use Kiosk, right? And also to make one thing clear, I am not the creator of Ergo Mixer. It's basically a joint work with Alex, and we only did the theory of it, right? The implementation is done by somebody else, and he's anonymous, so we don't know who actually implemented that. But I helped him. He contacted me, so I helped him with the basic code, and that was written on top of Kiosk.
So, once again, moving on from everything we've covered so far, one of the last things we should probably leave to the viewers to think about for the future of Ergo is the interoperability and functionality that is going to be coming out of the partnership with Cardano and Ergo as one. It was mentioned a bit prior to this, but maybe some expansion and insight could be added to it.
Sure. So what's quite interesting from an end user perspective, even if you don't really care about what a UTXO is, how do all these systems work, what are smart contracts, UTXO-based smart contracts, NEPA POWs, all these terminologies. What is cool is that the underlying model of smart contracts for Cardano and for Ergo are relatively similar. Because of that, we have a lot of potential for protocols we write in one ecosystem to work reasonably similarly, if not almost one for one, in the other ecosystem. Since Ergo is quite a bit more refined to some degree in regards to the mainnet being launched in July 2019, we already have a year and 3 months now of experience writing smart contracts, testing smart contracts, formally verifying smart contracts, and getting kind of a hand on how does all this work. We're still very early on. We're discovering design patterns literally, I think, on a weekly basis. And so what's really cool is that a lot of the things we're discovering and finding out right now, they'll be equally as applicable in Cardano and Plutus. So a lot of the work we're doing now is foundational, you could say, because it's defining how do you define an epic in a extended UTXO system. That's something that will be reusable on these two blockchains and probably on any other ones that eventually are created that also use a similar or the same model. And so what we're doing because I'm also head of research at Emergo. One of the directions we're pursuing in from that point of view is that we're adding support for Erg inside of Yoroi, and we're making Yoroi a smart contract wallet in the near future. What this means is that since we have this base extended UTXO model for both blockchains, and we're going to have both currencies within Yoroi, what we're going to try and work to do over time, no promises, this is just going to be in a month or two, but as we start to really develop and flesh out all of these pieces, we're going to start to merge the usability of smart contracts on Ergo and the smart contracts on Cardano. Eventually, we have NepoPows, so we have some interoperability there. There's potential for transaction chain and a lot of other ideas for how we can get the two blockchains to communicate. But eventually, the hope is that we'll have a stable coin on Ergo, we'll have a stable coin on Cardano. Maybe users who have stable coins on one blockchain can effectively use smart contracts in another blockchain if we abstract away all the layers that it takes for wrapping a coin or doing maybe atomic swaps or doing these cross-blockchain exchanges where the user would simply press confirm transaction, use their ledger or whatever way they confirm their transaction, and then we can essentially abstract away all the complexity of how do you get one stablecoin from one blockchain to the other blockchain to use this dApp. This is something we're actively researching into, and this is something in the long term which we want to achieve, is have this flexibility where a user has Yoroi as their go-to extended UTXO wallet, and they can use Ergo dApps, Cardano dApps, and it's all seamless and feels natural. And that's our long-term goal. And with that, we're going to work on improving the interoperability, not just for Yoroi users, but for all users of Ergo and all users of Cardano in the long term. And that's our goal.
So it really sounds like Ergo and Cardano are going to be completely interoperable, to say the least, and we're going to have these dApps and ecosystems existing in between each side of the wall. Well then, that marks the end of all the content that we have set out to cover today. It's fair to say we have provided a top-down approach, starting right at the top, working bit by bit, and seeing how the inner cogs of the Oracle pool framework is looking to operate. And to accompany that, Rob was kindly enough to just provide us with some insight into how things are working, especially in regard to the Cardano ecosystem and Ergo as a whole. If any of the topics we've covered today gather any attention from yourselves at all, there will be plenty of resource and direction down below just for you to indulge in what there is and what Ergo has to offer. Before I draw a close, is that everything? Would you like to add anything else towards what we've covered?
Okay, so then in regards on my side, one thing that I do want to mention is that Oracle pools are released and they're out there and they're available for people to just get into and jump into and run their own Oracle pools. We currently have 2 Oracle pools running live for everyone to check out with beautiful front ends created by Dedits, who is part of the developers who are building Ergo. And so you can go check out, go to explore.ergoplatform.com, I believe, and you can check out the Oracle pools live, see how they're running, see which stage they're in, and you can get a real feel for the Oracle pools yourself. But if you're a developer and you're interested in getting your first steps into how do I jump into the ecosystem, help build and run the underlying smart contract infrastructure, which oracles are really a key part of that. And maybe you want to, set your foot, be one of the first people to run Oracle pools outside of us who are developing them. Maybe make a name for yourself. Now's a great chance to do this because you have no competitors. And so now is a good point in time to understand what UTXOs are, understand the extended UTXO model and how smart contracts work, jump in, learn some Ergo script, start writing some smart contracts, start designing stuff, or just small iterations building on top of the Oracle core or Oracle pools in general. These are all things you can do today and actually get a lot of benefit from, even though the ecosystem might not be billions and billions of dollars. If you start today, once it grows to billions of dollars, you'll be one of the first people who actually, made an impact in the community, maybe discovered something, maybe made some key tooling, maybe ran an Oracle pool, which became the most popular Oracle pool, or, there's many options and directions which you can really invest your time into in the ecosystem today. And especially with Cardano releasing Goguen, most likely by the end of the year, the extended UTXO model seems to only be growing and growing and growing. Who knows how many other blockchains are going to adopt this stuff in the next 2, 3, 4 years, especially as we start to discover completely new design patterns, protocols that were never possible before on old systems. And so this is kind of the very beginning of a long hill where we're going up and we're developing and defining the key infrastructure that will really build a whole new ecosystem on the extended UTXO model. Now is the time for people to jump in, get started, and then the effect of that is that you'll have a lot of fruits for your labor. And so if anyone's interested, I recommend checking out the Ergo website, jumping into Telegram, coming on to the Discord. We're very friendly. The Discord is where we have most of our technical discussions. And so if you're interested in running an Oracle pool, building on top of Oracle pools, building a different kind of dApp, if any of that is interesting to you, then please jump in, talk with us, come up with ideas, start to write, your first contracts, and just get testing and get trying out what this new technology has available for you to build on top of.
So on that note, I'd like to greatly thank both of you, Amitabh and Robert. And to those viewing on the other end, we'll see you in around a month's time. Thank you.
Thanks.
Thanks.